Hey y'all, in this lesson we are going to take a look at geometric sequences. We want to be able to understand and represent geometric sequences. We still know what a sequence and a term is from the last lesson. However, in a geometric sequence, the ratio of successive terms is the same number. And this ratio we call the common ratio, or R. Our essential question is, how are geometric sequences related to nonlinear functions? We saw arithmetic sequences are related to linear functions. We're going to see how geometric sequences are related to nonlinear functions. In our first example, we will identify a geometric sequence. So here we have a ball and it is bouncing. On bounce 1, 2, and 3, it reaches these different heights, 280 and 32. We can figure out if this is a geometric sequence by looking from one value to the next and determining, is there a number that I am multiplying or dividing by every time? In this case, the values are decreasing, so I would think of division, but we do end up seeing that we want to write division as a fraction, so we're going to be multiplying a fraction in this case. And we do end up that fraction is 2 over 5, or 2/5. So we're multiplying by this fraction of 2/5, which really is showing us that division, or that getting smaller. So we can say that the height of the bounces shown in the table form a geometric sequence with a common ratio of 2/5. In this next part of the example, we will find the next three terms of this geometric sequence. We see 1, 4, 16, 64. So I want to try and figure out what is my multiplier here. I'm increasing, so I know I'm going to multiply by something. And from 1 to 4, really, what am I going to multiply 1 by to get 4? Well, I'm going to multiply by 4. And you might want to write in your notes that we are multiplying here. And then I look from 4 to 16. 4 times what is 16? Well, 4 times 4. And then I can check with a calculator, is 16 times 4 64? And it is. So I know that I am doing multiplying by 4 to get future terms. So I can take 64 times 4 to get my next term. I get 256. And then I can take 256 times 4, and the next number is 1024 times 4. And so these are the next three terms in my sequence, and I'm just using a calculator to help me calculate these out. So 256, 1024, and 4096. These are the next three terms in this sequence. Now you try this one. Find the next three terms in this sequence. One helpful hint is that when terms in a geometric sequence alternate between positive and negative, like this one does, your common ratio is going to be a negative number. You should get an answer for this one. We are multiplying by -2 each time, so we'll get positive 80, negative 160, and positive 320 as the next three terms in this sequence. So geometric sequences are non-linear. They can be represented by an equation though, and this equation is going to take the form of y equals a times b to the power of x. So we have x in our exponent. The value a we can get from the first term divided by the common ratio, and the value b is the common ratio. Just like with arithmetic sequences, the term number or the position in the sequence, such as first, second, or third, is the input of the function, and the term itself is the output of the function. So let's take a look now at being able to write a function rule for a geometric sequence. So here we can see our positions, and we have our terms 3, 6, 12, 24. So this sequence starts with 3. And to go from 3 to 6, and 6 to 12, and 12 to 24, I'm multiplying by 2. So my common ratio is 2. This means that my value of A, which is my first value divided by my common ratio, will be 3 divided by 2, which is 1.5. And I can get that simply by typing into a calculator 3 divided by 2. The value of B is the same as my common ratio. In this case, that's 2. So the equation for this is y equals 1.5 times 2 with an exponent of x. Remember that x is going to be the term position, so I could be like the 50th term and plug in 50 for x, and then I use a calculator to do that for me. Be careful when writing a function rule for a sequence with a negative common ratio. If you have a negative common ratio, remember to enclose that r in parentheses. For example, negative 2 to a power of 12 is not the same as that negative 2 in parentheses to a power of 12. So you can see if I have negative 2 and I put it to a power of 12 versus that negative 2 in parentheses to a power of 12 on a calculator, I get a positive or negative number. So it's very important that you are correctly putting it in those parentheses to show what it is accurately. Your final try it is to write an equation to represent this sequence. Here our first term is 3 and our common ratio is 5. So we get that y equals 0.6 times 5 to the power of x. I'll write that out just so you can see it. You could also write that 0.6 as a fraction. Let's summarize this lesson. A geometric sequence is a sequence of numbers that follows a pattern. The ratio between two consecutive terms is a constant called the common ratio. You'll use the form of y equals ab to the power of x to write an equation, where a is the first term divided by the common ratio, and b is the common ratio. Your next steps are to submit your 10.2 notes, complete your build 10.2, which is the last page of your packet, and then to take your 10.2 mastery check. Good luck.